Hello guys, it has been ages since last time I uploaded the YouTube video. So today we're gonna be doing some Python coding. And the question we're going to tackle, it is actually from one of my quiz uh, of one of my course I do at UNSW as a part of the information technology program. Okay, so this quiz is actually quite challenging. So let's just have a look at the question and try to understand exactly what this thing is asking. Okay, so let's just read the question. Okay, randomly fill a grid. Okay, that's already done by this boilerplate code. Okay, okay, here is what we want to do. We want to compute the longest and the leftmost path that start from the top left corner. Okay, that is really important. And a path consisting of horizontally or vertically adjacent one. Okay, so this thing is what basically gonna happen is the grid is gonna be filled with 0 and 1, and we wanna link all the ones that are adjacent to each other and make sure that the paths cross every one of them only once. Okay, that's really important. Only once. So, for example, if I have, I just want to simplify things. Okay, for example, if, well, let's say, okay, let's say that this is what happened. Okay, this is what we have. So there's 1 0 here. You have to find a way to link all those ones together by going through them only once. So you start from this grid. Okay, you start from this grid. So basically, what happened? The leftmost is that, okay, you turn. Like for example, I'm moving forwards, right? I'm moving from the east. So I'm now at this grid. Now, how is the path going to be drawn? It's like I mean, so this is moving towards the east. Okay, the leftmost. For example, we have something like this. Okay, so now this is the east. For example, this is north, and then this is south. Okay, so the first thing is like we want the leftmost. Okay, we're moving towards east, but we still want the leftmost, which in this case is gonna be n. Okay, now let's move to another example. Another example. For example, now we are moving towards what? Let's say we are moving towards the north. Okay, so what these two directions is gonna be? Yeah, this is gonna be west and east. Yeah, so the leftmost, once again, if we have a preference, so this will be the most favorable. So west followed by n and east. If none of these, west and north, none of these are available, we're gonna go to east. Okay, that's basically what this is happening. Okay, so for each time we test each grid, we first look at which direction it is originally heading towards. Okay, and from that point we can have 3 choices, and the one on the left is the most preferable choice. Okay, if that is not available, we go straight ahead. If that is still not available, we go right. If none of these options are available, then we say, okay, we can't go any further. We cannot go any further. Okay, that's basically what happened. So in this case, it's like we're coming from the east. Then we look at the north, towards the left, from the perspective of the agent. Okay. So now We look at the left, which is the north direction. Nothing. We got absolutely no way to go. So the second choice is to go forward, okay? Which means we move here. Now let's look at it again. We're coming from the east. We're moving towards the east. Coming from the west, moving towards the east. So now the left will still be moving towards the north. Then the second option, which moving towards north, is not the option. And moving straight ahead is not the option either. So our only option is to move down, which means move towards the right from the perspective of the agent. So now we over here, okay? So now the agent is now heading south, heading towards the south. So the left of that southerly direction is going to be east. Let me just demonstrate this, okay? Now we're moving towards south, yeah? And the left of the south is going to be east, yeah? And the right of the south is going to be west. Of course, north is over here. So now we take the most favorable direction, which is east. So now we move east. Okay, so you tell me what's the next one? I mean, obviously, we cannot go towards the left because it's blocked by one. Going forward is also not available. It's out of the boundary. So the only option is going down, which is going towards the right. Turn right from the perspective of the agent, and so on, so on. So eventually, using this regime, okay, we're gonna know this is how the path is gonna be, okay. So now let's talk about how we're gonna implement these structures, okay. We're gonna use a queue, and but for now, let's just implement the easiest, the initial structure of this. We're supposed to fill in this leftmost pass from top left corner function. Okay, so it's actually the initial step. You're gonna let's just do dimension. The dimension of the grid is the length, then grid. Okay, that's pretty simple. So now, and we can have now our first initial condition. Okay, our first initial condition is if grid. Okay, we're talking about the starting grid here, ij. Obviously, it's gonna be 1, 0, and 0, which is top left corner. Okay, so if that is not equal to 1, then the path is gonna be an empty list, right? So we're gonna return that path. Okay, so that is the first case down. Let me just remove this path. Okay. So now else is for all other cases, and that's where things get really tricky. Okay. We need to talk about the queue structure. So what is a queue? A queue is basically a list. Sorry, let me just change the color. A list of 1, 2, 3, 4. Okay, normally if you append a new element, you add at the very at the front, which is over here. For example, I want to add a new element 5. It will always come here. There's no way to put it at the front, right? So the queue is slightly different. This queue is like it's like you can pop. You can remove, pop out an element. For example, I can pop out a 1 at the front. Okay, I can do that. And So let me just get some naming convention, right? So this is gonna be the tail, and this is gonna be the head. Okay. So let's thinking about why is it called a queue. It's really simple. Yeah. Why is it called a queue? For example, this first person. For you, if this is a counter at KFC or at McDonald's, a customer lining up, right? This is a counter waiting to be served. Okay. So the dequeuing process, which means reducing the people from the queue, is going to take place over the tail, right? For example, so once we dequeue, the customer one has already been served. Okay, that is what happened. And if that's new customer, for example, the customer 6 is gonna join at the head of the queue. Okay, the queue is gonna move in this direction, waiting to be served all the customers. And once a 6 is joined here, this head will change from 5 to 6, right? And once the customer one has already been served, we remove that. The new tail is gonna be 2, right? So you think it's like it's kind of like first come first serve, first come first serve basis. So why is this structure important to our quiz? It's like all these queues, all this element is gonna be our possible path. So what is actually a path? Let me just draw out something for you guys. A path is basically a list of tuples, right? For example, if we got a grid that is like 1, 1, 1, 1, 0, 0, 0, 0, 0, right? So what are the paths? So what is the path that's gonna go through all of these grid, all of these ones, only once, and maximize the length? Okay, so remember that we were talking about we want to take the leftmost, right? So it's gonna be the top one. So it's gonna be 0, 0, and 0, 1, 0, 2. Okay, this is our preferential path. Obviously, there's still another path. There's another path which is 0, 0, 0, 1, and 1, 1. Okay, so we want the top one. Okay, so there's something to remember. If we talk about the queue here, right? We are dequeuing each one of them, and we want the very last element, which is gonna be the longest queue and also the leftmost. So what you're gonna do is, because the queue is the first come first served, last come last served, okay? So you kind of need to if you want the last element to be the leftmost, you need to add that. For example, this element. Let's treat this path as an element. This thing needs to be added to the queue the last. Remember that. So we need to add this one first. So that is something, it's the opposite of the, so when you are in queuing, it's actually the opposite of the, the leftmost regime. For example, you actually, when you are actually adding those paths to the queue, you want to add the path that go to the right first, okay? You want to, when you are adding those paths to the queue, you want to add the paths that go to the right first. And so that the very last element of the queue is actually going to end up being the one that that actually turn to the left. Okay, I know it's a bit counterintuitive, but if you think about the queue, first come, first serve, last come, last serve, the end of the last one is the one you want, which is the leftmost. So the first one you should add is gonna be the one that actually prefer a rightward turn. Okay, so that's something I sorry about. I know it can cause a lot of confusions, but that's how I understand it. Okay, so let's start coding, right? Let's start coding. I think it's really time to do that. So let's define some important some variables. Okay, some dictionaries to hold our values. So going north. What does going north mean? For example, if we start our original, for example, our current position is 1, 1. Going 1 degree north, how is the coordinate going to change? So obviously it's going to be changed to 0, 1. Okay? The x and y, x is actually our row number, and the y is our column number. So that's something to bear in mind, okay? So basically, going north, okay, this action reduce our x by 1, okay? And going, so you tell me what going east is gonna entail. So going east, you're gonna increase this column number by 1. So basically, going east will not change our row number, but will change our column number. So this is gonna be 0 and 1. So, and while going south is gonna be 1, 0, right? You're gonna increase your row number. And going left, going west, yeah, going toward the west, it's like you're gonna reduce the column number while keeping the row number unchanged. Okay, so here is how we're gonna implement. So firstly, we're gonna define how we're gonna change our direction. Okay, so and it's gonna be a dictionary. So we have 4 directions. So we have 4 values. Four keys and 4 values, right? So let's start with the north. Okay, let's start with north, and the value is gonna be a list, which is gonna be -1 and 0. You can use tuple as well. It doesn't really matter. Okay, so this is the west, and east is gonna be 0 and 1, and south is gonna be 1 and 0, right? Hope I'm not getting anything wrong here. And west is gonna be 0, keeping the row unchanged, and the -1. I think that it should be, so these are the actions, okay? All the possible actions we can take, okay? It's like 4 different directions, and their effects on our current coordinate, our current position. So now it's time to construct a structure that contains our preference. Like what I mentioned before, in order to get the leftmost path that pass through all those that maximize the length of the path, you need to do the opposite, because when you adding those paths to the queue, yeah. So you need to do the opposite. You should need to prefer that you're gonna prefer a rightward turn over a leftward turn, right? So let me just draw something. So the priority level is gonna be right, central, which is going straight, yeah, and the least favorable option is actually going to be turning left. Yeah, this is happen when you are trying to add in queuing, okay? Join the in queue process. So let me just define another dictionary, actually, another dictionary, and it's gonna be oh, I never get this right. The alignment is so annoying. Okay, but now it's like, so right now, for example, if our previous directions, the previous direction is the one that you are heading towards. For example, originally the agent is heading towards the north, okay, and obviously the preferential, the most favorable action is actually gonna be turning right. Yeah, this agent is gonna be wanting to turn right. So the first most favorable option is gonna be east, right? Let me just, if you still don't understand, um, let me just explain. For example, you are moving towards the north, okay? Then our priority level, the most favorable option is turning right, which is going toward the east. So I'm gonna put, sorry, I think it's a bit all over the place. It's the dictionary. It's gonna be another list, right? So it's gonna be in a string, right? And so this is gonna be 1, 2, 3. Yeah. So turning right is the most favorable. If that's not available, and the second is actually gonna maintain our headings, which is going straight ahead. So this is gonna be north again, yeah, and then going west. Okay, so each of these each of these keys has only 3 values. Okay, so likewise, cells is gonna be. So what is let's see what's happening. Okay, let's see what's happening. We're heading toward the south, right? We're heading toward the south. So what is to the right? What is to the right of south? It's west, right? So the first option is gonna be the west. The second is gonna be the same as the original direction. Keep the heading. And the last one is gonna be east. Okay, basically, sorry, I made a mistake here. Let me just see. Okay, that's good. So I think the rest it should be pretty easy. I'm not gonna explain on here again. Okay, so east, north, south, east, west, whatever. This is gonna be, yeah. So guys, when you are trying to figure this out, you can always just pull out your pen and pencil. You know, when you are coding, I think if you can't visualize things in your mind, you always draw things out. Yeah. I mean, that's the way to do it. I mean, just choose the way that suits you the best. Okay. Let's just make life a lot easier, I think, in my opinion. And so the next one is gonna maintain the headings. Okay, it's gonna be north, and well, obviously the west is gonna be north, followed by west. Okay, and south. So why is my bracket all over the place? I think that's alright, right? Pretty neat and tidy. Okay. Alright, so we have defined these are the actions and these are our preference, our choices, okay? So these choices obviously later on will be fed into the change direction in in a kind of a mechanism. All right. So I think I'm gonna pause here, and I'm gonna see you at part 2, where we're gonna continue and finish this quiz. Thank you.